So hi guys, again I'm back with my another internship project. This project is based on unsupervised learning using k-means clustering. Yeah. So we have imported as usual the necessary models and libraries of the pandas. Here you can see we have imported k-means library package. The first step is to import the data. So our data looks like this with four columns, numerical columns and one categorical column. So if we want to know about the data set, we'll type info, and here you can see it has six columns and total 150 entries, with five of them are float values and int values. But the last one, it is not string but rather it is object. So for dataset it is not a string, it's an object. Okay. The next step is df.describe, where you can see here we have not get the last column, which is categorical column species, because it does not include any mathematical numerical values. So to count mean and max values, so only five columns are added. Now in species, as we have categorical data, we can choose how many, and we can count how many different values of uh, different values are present in this column. So you can see there are three varieties. Their count is 50 50 50 each. So each is of 50 count, and these threes are the main data variety of data present in the species column. So for as the first step of k-means, we have to apply an elbow plot method. Using this method, we probably find the value of k, which suits k-means number of clusters you have to find. So after importing these clusters, uh, we have created SSE arrays, and here using range from 1 to 11, because we think we have data from number of clusters lesser than 10, so we are taking just for number 1 to 11. And you can use number of clusters that equal to I, which ranges from 1 to 11. It will continue till you can find the best value. So in it, here you can put random also, but k-means plus plus is the fastest method and efficient method, so we have applied that. Here you can see SSE is the array which contains all the squared error of the values. So the value with lowest, or you can say optimum value of SSE, that is the our cluster, means value of k. So I have plot this, and you can see it is like an elbow. So these two are pivotal point, you can see. Now to determine this, we also need to install need, but though in this case you can see manually, but in many cases you cannot, so better to do with the coding. So for that you will need KNIEED package, Here we have installed that, and from that we have to import nil locator and data generator, and it automatically find out the that point optimum number of value of k. So here kl dot elbow is equal to 3. So this is the value of k. Now we have found out the number of clusters we have to group in. We have to group this data. Now to better accuracy, we have to do feature scaling. So you can see here our data was looking like this before. Just focus on the numerical data, and then now this is our data after applying feature scaling. These are the 4 columns respectively. You can see it is stored in array form, not in the data frame. Okay, now we are building our model. So we are training it and predicting the values and storing it by k means. Okay, now the best part, as well, to visualize the data so that we can find any discrepancies between the data. So these two are the graphs. You can see this is the graph between sepal width and sepal length using first 2 columns only. So here is the method to plot it, and these are the centroids 0 and 1. So 0 means the first column, 1 means the second column, which is sepal width and sepal length. So here with coordinates, these the data look like. So this data has 3 main varieties: Iris setosa, Iris versicolor, and Iris virginica. Okay, the next plot we are doing with the third and fourth column. So this is the column petal width, and this is the column petal length. So here you can see the data looks different here in this view, and these are with the 3 its coordinates. Okay, and the next part is here you can see all the data with respect to each other. Here are the column names: sepal width, sepal length, petal width, petal length, and here also the same: sepal length, sepal width, petal length, petal width. So here you can see this data. Yeah, here you can see the clustering in different parts, and I have plotted among these the two graphs, so you can actually, this is the original data, original clustering, and this is k-means clustering. So this graph is different from this all graphs. So if you find out the petal length and petal width graph, so petal width and petal length, so this is the data which looks like this, and here is the same you can use as look like this. Okay, yeah. Now the next part is to better visualize that all data in the 3D format. So I have used 3 columns, namely petal breadth, sepal width, and sepal length. So here you can see the 3D graph, and here you can rotate it so that you can see what it looks like. Here you can see these 3 clusters. I'm rotating it, okay, so that you can see in a better view. Yeah, you can see here the three different called clusters: this, this, and this. The blue one is iris vesicula, the red one is iris setosa, and green one is iris virginica. And this is the better way to apply and plot the data. And 3D graph allows us to visualize it more easily. Yeah. So thank you. This is my project, and hoping to do the next and uploading it soon. Thank you.